How's it going, everyone? Eulier Gonzalez here again. Looking at the React performance course as a way to look at how you can now write React components in the most performant way, therefore React applications. But before that, you need to know what is React and how React works behind the scenes. This is a course taught by Steve Kinney, head front-end engineer of Temporal, this open source tool that is a durable execution platform that companies like Vercel actually is using behind the scenes. And you can pretty much think like a oh sorry yeah, you can pretty much think like a Kubernetes to cover specific business use cases. So why this is important as a way to describe who is Steve Kinney and that kind of thing. As a way to now not only to validate his experience, the course, and also look at why it's important to learn about what is React, how that works when it comes to actually solve any performance issue, which is something that you're going to find a lot of the time out there in a lot of clients in their business. And then you now not only have the ability to solve that problems, but you develop a tool set that when those problems arise, you can come up with some best practice. And to improve your technical skill, which is something that is very, very useful along your career, especially in my case with English, and make it all of those abstraction meaningful to others. So you're not only able to empowering a team to actually build or fix a particular features, but also to drive the business as and the company, so they can now align that features that they build to actually solve specific problems for their clients, for the shareholders, and the business itself. So one of the things here is that when we are able to look at that, specifically to the core structure, introduction, React rendering, reducing rendering, context, suspense and transition, the thing here is that by looking now at so far we're gonna recap this React rendering and all of the, as a way to jump straight forward to the escape hatches here, like so. So one of the things so one of the things of that is that of looking at this several topics, especially of the intro, I'm going to make a quick recap here, is to, from the perspective, at least from React, and I will argue for other systems, is that it is way much faster to not doing things than doing it. Which means in terms of optimization, in terms of priority, it is better to not doing that stuff rather than doing it. Especially if that is not a priority, right? And this is something that you can apply that to your life. Is that is a priority? Yes, go for it. If not, don't even think about it. Focus on yourself. So, because of that, all right, as a way to now look at the different recipe that you can do, especially when you need to optimize React application, is like look at the production build, check if they are actually using the production build. Also take a look at the component hierarchy and state, start from there. Then you're going to take a look now at the rendering strategy, whether it's use Mimo or use callbacks and that kind of thing, as well as the way of how now they are actually loading is different piece of components or page using the suspense API. And if you're really in a pickle, well, then look at how you can now is use transition. So for example, as a way to now run concurrent renderings, or if you need to defer some rendering, use the defer value as a way to put this rendering prioritization. In any case, yes, because as a way to understand now how React works, we need to look at this specific section, the learn model. Okay, I'm not going to dive deep into this topic. In fact, I'm gonna just move on to what we really care about. So, after all, React is just JavaScript framework that allows to describe its DUI using JavaScript functions. We look at how can we import them, export components, how can we use JSX as a way to now combine the JavaScript and the HTML, pass down data to as argument in your or as parameter in your function, conditionally render that component, send rendering is a list of elements using the key, for example, and how now you can is or how important is for React to think anytime you write your React components to make it pure as a way to now give you some benefits. So now you have the ability to run these React components in any JavaScript environment. For example, the server, when you're going to receive some data from the database, as a way to populate is this specific React components with relevant data that you're going to send that to the user or to several users, all right? As and how you can now is catch your components as a way to stop as a way to prevent or to save computational times using built-in features like use memo, use callback, and that kind of thing. All right. And also, when it comes to now stop the rendering execution, how safely you can do that as a way when you need to pass down data, when you need to stop the execution so you can re-render this your render tree. And and what is the render tree? What is the tree of dependency? Then how now we can add interactivity to the React components as a way to say, great, we can create now our HTML or JSX element, but if we don't add any interactivity or we don't provide any way for the users to manipulate the data, we essentially are just creating this HTML. So we look at how you can combine now is or adding the interactivity through by adding functions to the event listener, how you can now show some data or remember things in your components with states, and how now states allow you to is showing some data and update that data when you see fit, whether it is when the user, when there is a computer or human inputs that update that state. So the idea of this is that when we are able to see how you can now define this state, how you can remember data like that, is to what happened when you actually update the state, when you actually update what these components remember, right? And that is the rendering mechanism, which is passed through the trigger, render, and commit phase. So the trigger is when this state update happened, it was caused by the root element or for any component or any of its ancestor that update that state. Then on the commit phase, it say, okay, now let me now compute or let me now run this function. If it was caused by the root element, what it's going to do is to now render that element, or in other words, it's going to is create those elements using the react.create element. Okay. If this was caused by a re-render, then it's going to call the component that caused. Sorry. You're going to call the component that triggered that state updates, and then compute all of its props, states, and local variables, which at the end of the day, they are all reactive, something that we're going to talk about that in today's video. And then it is time for verify if the output of calling that function, which is a JSX element, contains more React component. If it is, it's going to call all of those components in a recursive way until there is no more components there. So that's great, that's fantastic, because once it calls that, all right, when React is doing that, it recreates this thing called the VDOM. And the VDOM is now this ideal representation of the UI that is kept in memory and sync with the real DOM. So you can now is just scratch. So the VDOM is this ideal representation of the UI that is kept in memory and sync with the real DOM. This particular process is known as the reconciliation process, and this is what allows you as a developer to interact with the React API and now indicate to React what state you want your UI to be, and then you let React to match that state with the DOM. And this is something very beautiful because now instead of you having to manually updating each one of those elements, let's say the attributes or DOM manipulations or event handler, you delegate that to React. You can focus now on this topic. And I think this is what is going to be, this will be the norm from this moment and on, as a way to now is instead of actually understand how the things work, which is important, understand how all of this machinery work, okay, you will now is as a way to understand how all of this machinery works, you will now is having an abstraction layer. So in other words, you are not care about what's going on behind the scenes. You are assuming that that particular system or tool actually do the thing and do a great job at doing that, which is updating the DOM. So you can now focus on more ambitious goals. So for example, creating UIs or more ambitious application and that kind of thing. But the idea of that is the computer science is now more than ever rely heavily on all of this abstraction. And because this is quite convenient, it's because this is convenient, and convenience will be is our greatest tool and detriment. Why is that? Because if you don't understand how all of those low-level things work, then when that layer is dead, or when you can understand, when that particular tool doesn't work or gets broken, or you don't have then you need to actually go to the low level things. Some people say it is uncommon that you're going to access that, but that doesn't mean that you don't need to know what happened and how that works. But in any case, okay, so on that topic, okay, then I look at Then I look at something interesting here, which is now um, the commit phase. And before going to that, to there is something called fibers, which is now is additional information that is added to this VDOM, and React Fiber, which is the reconciliation engine that is what's built on React 16 as a way to lay down now all of the features that we can enjoy right now. So, for example, the ability to pause, resume, or stop a rendering prioritizations using use defer, or concurrent rendering using transition or use transition. It, this is just now back then in React 16 lay down the foundation of how this particular things actually works. So with that, then on the commit phase, if those change states or is that state update happening at the root element when the component is get mounted on your application into the DOM, because on the previous step we actually create all of the elements. Now it is time to append using the append DOM API to the uh, root elements, and then it's going to show all of that elements on the screen. However, if this was caused by a re-rendering, now it is time is to apply only the bare minimum necessary change, as long as they are different between renderings. The browser detects those DOM updates and then repaint or paint your UI. And this is a mechanical process that happens over and over and over and over and over. It might be at the beginning quite intrinsic or quite finicky to understand that, but once you understand that, it's like there is no magic in there. It is just mechanism. It's just science. It's just a habit, or a mechanism of how this thing works over and over and over, and that's pretty much. And especially with this kind of thing is that these are human-made technologies, which is great, because now any human can understand that. As long as you can now read a tweet and be able to brush your teeth, wash your clothes, hit the bathroom, eat for yourself, you can do this. So now that we described the rendering mechanism, we also look at how we can is now think of a state as a snapshot, how the state are synchronous, which means that how states are asynchronous, which means that the states, the variable values, state updates will be reflect in the next render. And when you're going to update your state, you can think of that during the event handler. You can think of that React fix that state for you. And also how you can now is include series of state updates as a way to now is send a series or work with the previous state using now the using now is the using now is anyway. Yes. Using now is that. Right. So then we look at now how can we update our objects and array in a state. The TLDR is always returned as a new state, and use IMER as a way to make your state consist. You say update consist. and how now you can, when it comes to managing your states, aka when it comes to now building your UI state, how it's important to think of your UI state as states change, uh, by visualizing, yeah, by things that not going to mention that. Also, how you can now is organize your state, and when it comes to now share that state across different components, how useful is to think of them as the source of truth, and why when you think of that, then Redux tools becomes actually like crystal clear, or like lens. It's like, oh, now you know when to need that. Not only that, but also is that how you can now, for example, preserve or reset the state in a component. Okay, uh, and when it comes to react to more, when a state needs to react, or the more input and a state needs to react to, yeah, the more input a state needs to react, okay, the more inputs a state needs to react, whether it is, for example, um, computer input or human inputs, uh, how helpful is to have a consistent and maintainable way to make our state update logic simple, right? That's what we have reducers for that. And when it comes to now pass down data, how useful is to use context, but it comes with a trade-off, because the problem that solves context is this known as prop drilling. However, you might feel tempted to overuse context as a way to, every time that you need a state, you're gonna put that in a centralized place. But React recommend that to only use it for specific small app level state. For example, theming, or for example, user authentication, analytics. Uh, for example, React Router actually use context as a way to keep track is what is the current URL of the user, uh, and when it comes to now is uh, deal with more and more or the more state that you want, the more input that a state needs to react. Okay, using with reducer as a way to manage your state update, to keep them consist and maintainable. When you combine that with the context as a way to now centralize that state, and then those components that make use that, now they can access, and then you have much more control about that. The caveat is that any components that use that uh, context, uh, React will gonna re-render from it is providers, or starting from the provider, that value change. And now here is when we use, for example, uh, memorization techniques, or catching strategies, like use memo or use callback, as a way to prevent to those functions or computations actually be computed every time that component is called. So only do that when an array of dependency change, which means that when I, as a developer, as an author, I tell you to change that. That's quite interesting and beautiful. So with that, now, okay, the idea of all of this is to say, well, since we look at now how we can manage our states, and when it comes to actually interact with external systems, so for example, focusing or access the focus on an input using the browser API, or play or pause a video without a React without React component. Perhaps you want to use this with sorry. Perhaps you want to use this. Yes. Perhaps you wanna is now connect to a server and then receive message from that. So when you need to connect to external systems, okay, uh, most of the logic of your application and the data flow shouldn't rely on this feature, according to React docs. So even though, for example, if you need to have a place, recycled place to store data between re-renderings without triggering a re-rendering, you can use this useref. And there's specific use case for that. Timeout ID, the grabbing an element or storing a DOM element that you want to operate on that, and also any object that you want to get or that you need to store between re-rendering that are not part of the GSX calculation. All right. So, for example, let's say the 3GS, for example, or some libraries that actually needs to render components, that kind of thing. In any case, the point of this is that by doing that, and mhm, so by doing that, so by doing that, or by using is the useref, okay, and understand when the useref fits in the entire mechanism, rendering mechanism. So, for example, you have now is the you have now is the how do you call it? Um, yeah, you have now is the use with useref you can, so the useref fits into the rendering mechanism by being initialized before the commit phase and then assigned after the commit phase. And how when it comes to work with the DOM elements, specifically with scrolling or knowing the size of an element or focus on an input, okay, which is most of the time the use case of use ref, you can do that. And we also look at how can we do that. However, when it comes now to synchronize with external systems, okay, you going to use something called effect. An effect is just a hook from React that allows you to run a specific code after every render. Before that, we need to understand the type of logic that can exist in your component, whether it is the rendering logic that must be pure and the event handling that is in there where you can perform some side effects. So, for example, network calls. So the React developers say, hey, you know what? It'll be great, it'll be better to actually run these side effects that are caused by rendering itself after every commit phase. So this is when it comes to describe is the effect of how you can use effect. You say, okay, now I want you to now I want you to do this. Give me a second. Uh, Now I want you to do this. So because we are here to defining is the React rendering, that kind of thing. Okay. Ooh. Because now, when I look at the synchronizing, or when you look at how you can describe a use effect by using the use effects, and this by default will run after every commit phase. Most of the time, you don't want to do that. That's why you have now an array of dependency, and also you need to define is the cleanup function. When you are in the development mode, React, to prevent some common gotchas and bugs that happens in your states as well as in your effect, it will rerun your components twice and rerun your effect. It's going to re-render your components and rerun your effect twice. Okay, so that's instead of actually see how you can get rid of this duplication behavior, find a way of how you can fix your effect to work with the cleanup function. And that's when we look at the anatomy of the cleanup function, something that we're going to dive deep too much. But when you write your effect, this will typically fall into these patterns, whether it is the okay, so whether it is the connecting to a non-React widget, which is one, or yeah, connecting to a non-React widget, or for example a map, Macbox, and that kind of thing, or to an animation, subscribing to an event, or to or data fetching. So when you do this data fetching, one of the patterns they say is to use is ignore. You can also use abort, but most of the time you use is ignore as a way to now, since there is no mechanism to undo a network request, so that's why you have now this flag called ignore. And when you're going to run this function the first time, the use effect you run is the setup code, and if one of those dependencies change, okay, then you want to now is ignore the previous side effects, and now with the old state, and now run is the new state or the new setup code with the new state. So this particularly is, again, it works quite decent, but it comes with some challenge. So for example, the effects are not running in your server, because the way how now the server works is by rendering that HTML and serve that to the client. It now shows the loading page. The client don't load the JavaScript, only to realize that now it needs to make a request to the server. So you have now, you need to deduplicate is network request there. The other is that there is no catching, because since your components now is, so since your component needs to now is sometimes you want to store that information, but anytime you mount, unmount, and remount the components, you have to now make that request again. There is no catching mechanism. What you also going to now have this waterfall network. For example, a parent needs to fetch specific data, the child as well, the grandchild, and so on and so forth. A good analogy of this will be, for example, in your bank account, for example, you have a model that actually fetches the balance account, the other is the transaction history, the other is the user data, and that kind of thing. So now you have this network waterfall, which of course make your app slower, and also that you need to deal with race conditions, which means that what happens when the users want to send several times this same request, you only want to get the last one. Okay, so because of that, frameworks like Next, Remix, and Gatsby actually now provide this built-in data fetching and catching tools. What you can use is this client-side data fetching and catching, like React Query, SWC, as well as use router 3.4. Or you can implement your own by using this effect and avoid is the duplicating requests, network waterfalls, and uh, and catching the response, which is not a trivial thing, like routing. Okay, so and last but not least is you can use this now as effect as a way to run your analytics. So when the page is loaded, now you want to know how many times a user is actually watching this application or this particular component. So because of that, we also look at when you don't need an effect, and most of the time is when your code, your side effect, doesn't need to synchronize with an external system, you don't need an effect. If you find yourself to compute is or to transform some data, you don't need an effect. In at rendering, you don't need an effect. If you find yourself with handling logic inside of your so for example, something that they mention here is like you don't need an effect to handle user events. Okay, and now it shows a long list of things. So for example, remember that at the end of the day, think of the effect as the way of how you can synchronize with external systems. That's all. That's all. So you can think of states in these two phases. You start to synchronize with an external system and then you stop it. So this is a couple of things that we look, especially when you need to consider to use an state, when you don't need to use an state. So for example, updating an state based on a props or state, and I think this is quite interesting because it can give you a lot of most common bug fix that you will encounter when you are going to develop your application, right? So because of that, updating a state based on props or states, that's one of them. Okay, that's one of them. In here you say, well, if you need to state an state based on props or states, so recompute that, recalculate that. The other is catching expensive calculations. Well, it is better to use techniques like or building tools like Mimo for that. The other is resetting all state when a prop change using the key, adjusting some state when a prop change. Here you can also is compute that. So you're going to define as a new state, and then you therefore is to compute that as a way to get that. Sharing logic between event handlers is like you don't need an effect to do that. Again, to deal with user inputs, you just create just a function where you're going to share that logic across event handlers. Sending a post request, you don't need to use an effect. In fact, you use an event handler. Chains of computation, this might be quite tricky, but the idea here is that it's inside of your event handler when you're going to actually verify is all of these chains of computation or chains of state updates. And when it comes to initialize your application, you're going to put all of that logic is inside of your entry point. Your app, for example, you can put that as the inside of your app component, or before the component. So when the entire application is mounted. Notifying parent components about state change. So you don't use an effect, you use an event handlers as a way to emit that or this inverse data flow. And the other is passing data to the parent as a way to say now, instead of actually notifying about this state to my parent, I'm going to lift the state up and then pass down that data. Following is the one-way data flow. And subscribing to an external store. This might be quite very narrow specific. One of the use case for that is to use now the use sync external store. That, for example, sometimes your component might need to subscribe to some data outside of the React state. And this data could be from a third-party library or built-in browser API. Since this data can change without React knowledge, you need to manually subscribe your components to it. This is often done with an effect. But as you can see here, since this data can change without React knowledge, yes, since this data can change without React knowledge, you need to manually subscribe your components to it. Since this data can change without React knowledge, you need exactly. So for example, sometimes your component needs to subscribe to some data outside of React state, and this data could be a third-party library or a built-in browser API. Okay, when it comes to actually subscribing to external store, you might feel tempted here, which is okay. You might feel tempted to use an state in your components, right? As a way to sync with external systems. Since this data can change without React knowledge, you need to manually subscribe your component to this. This is often done with an effect. For example, like this. Here the component subscribed to an external data store, in this case, the browser navigator. Exactly. You're subscribing to this. Okay. So you're subscribing is to this okay, you're subscribing to this external data store. For example, here. Since the API does not exist on the server, so it can be used for initial HTML, initially the state is set to true. Initially the state is set to true whenever the value of the data store changes in the browser. The component update it is state. Although it is common to use effect for this, React has a purpose-built hook for subscribing to an external store that is preferred instead. Delete the effect and replace it and call to use sync store. So for that, if you want to subscribe to that, you're gonna run that callback, which is gonna pass through the subscriber. Okay, and then you're gonna see what is the API that you want to subscribe here, the external API that you want to subscribe. Subscribe. React won't resubscribe for as long as you pass the same function. Navigator.online and this. Use external store here. Good. Subscribing to an external store with a built-in hook. The navigator and true. And counts is offline use online status. This approach is less error prone than manually sync mutable data to the React state with an effect. Typically, you will write a custom hook like use only status above so that you don't need to repeat this code in individual components. bring more about subscribing to external store from React components. And the other is fetching data. So you don't need to use is, or in this case, when you're going to use exactly, if you're going to use an effect with for fetching data, you must ignore that because you want to also prevent some race conditions and add in the cleanup function. And I think this is quite interesting. This is not a problem for React, but for any UI library like so. So even though, although this alone won't be as efficient as using framework building data fetching mechanism, moving the data fetching logic into a custom hook will make it easy to adopt an efficient data fetching strategy layer. Because by abstracting that logic into their own custom hook, for example, you say, hey, use data, and here is by extracting that data into their own custom hook, now you will be able to do that. So the recap here is that, and especially of the life cycle of reactive effect. So finally, here we are. This is something that I'm quite familiar with. And here in the life cycle of reactive effect, they say, all right, it is important here to think of your effects that do two things. They can only do two things. Start synchronizing something and later stop synchronizing. That's the life cycle of reactive effect. That's interesting. An effect can only do two things. Oh, the life cycle of reactive effects. They call this reactive effect. Interesting. So effects have different life cycle from components. Components may exactly. So effects have different life cycle from components, and here we're looking at the life cycle of reactive effect. So you can an effect can only do two things. So start subscribing to something and later stop synchronizing it. Okay, this cycle can happen multiple times if your effect depends on props and state that change over time. React provides a linter rule to check that you have specified your effect dependency correctly. This keeps your effect synchronized to the latest props and state. This keeps your effect synchronized to the latest props and state. So, but the idea here is that this can happen multiple times if your effects depend on props and state that change over time. That's right. So there are only two things that your effect can do, and that is start synchronizing something, and later on stop synchronizing it. And this process can happen multiple times if your effects depends on props and states that changes over time. So start synchronizing and then later on stop synchronizing, and so on and so forth. Remember that in development we have now that our components are re-rendered twice, as well as our effects. So React provides a linter rule to check that you have specified your effect dependency correctly. Okay. React provides a linter rule to check that you have specified your effects dependency correctly. This keeps your effects synchronized to the latest props and state. And also React provides some linter rules that check that you have specified your effect dependency correctly. So first things first, we look at the life cycle of an effect. We look at the React component cycle, which is mount, when the component appears on the screen. Then the components update when you now trigger an state when it receives a new props or states, usually in response to an interaction. Okay, when it receives a new props or a new state, it will update the components. Therefore, it will re-render the component. and when the component is unmounted, when it is removed from the screen. So it is good to think your effect as independent life cycles. So for example, like this, each effect has a separate life cycle from the surrounding components, and each effect describes a separate synchronization process that can start and stop. And I will stick with this, okay? Each effect describes a synchronization process that can start and stop. This process can happen uh, many times, as in that many times, whether it's based based on their props or states. And now the effect, okay, and now the linter provide is this kind of thing. And now the linter provide this kind of thing. The React linter provide now is recommendations to prevent some common errors there. So when you write and read effect, think from each individual effect's perspective, how to start and stop synchronization rather than from the component perspective, how it mounts, updates, or mounts when you're writing is this. Okay, let's get into this. Values declared inside the component's body are reactive. Values declared inside of your component's body are reactive. So for example, if you define a constant or any value there, it becomes reactive. Values declared inside the component's body are reactive. And reactive values should resynchronize the effect because they can change over time. The linter verify that all reactive values use exactly the linter verify that all reactive values used inside the effect are specified as dependencies, and all error flagged by the linter are legitimate. There's always a way to fix the code to not break the rules. So, and I think this is quite something interesting. So every value or values declared inside of the component body, which is a function, are reactive. Why this is reactive? Because at the end of the day, those props will be reevaluated, will be processed, and whether it's with the props or state or with your variables or values defined there, but that usually is depends on its props or on its states. That's why they becomes now reactive, which is they change when the rent or they change when they change over time, and they change over time based on whether it's an state update or a props update. Okay. Fixed reconnecting of every keystroke. When you don't want to resynchronize that. But again, the entire point of this is to say, think of this as resynchronize. When you write and read effect, think from each individual effect's perspective. Where am I going to synchronize, and when I'm going to when I'm going to synchronize, what I'm going to do when I synchronize and stop doing it. Okay, what I'm going to do when I start synchronizing and stop doing it. Okay, values declared inside of the component's body are reactive. Reactive values should be resynchronized the effect because it can change over time. So, fixed reconnection of every keystroke. So here you're using is this, and then you want is to, on every keystroke, you want to reconnect that, which means that as long as you have an state associated to that input, which is now updating when the inputs change, you can now is, because first you define the startup function that is initially is going to run as the setup code, okay, and then you have the cleanup code. So followed by here you say, all right, hello, all right, I want you to now, whenever the message, or in this case these reactive values, and any value declared inside of your React components are reactive, therefore they change over time, whether it's local variables or states or props, okay. Whenever the message change, I want you to now is it say, hey, there is a missing property here, like server URL, but in particular is the room ID, okay. So then I need is to actually is pass is the room ID. So because the idea here is that it wants to connect after every re-rendering like this, fixed connection on every keystroke. In this example, the chat mount component connects to the chat room when the component mounts, that disconnect when it mounts, and reconnect when you select a different chat room. This behavior is correct, so you need to keep it working. However, there is a problem. Whenever you type into the message input at the bottom, chat room also reconnect to the chat. You can notice this by clearing the console and typing into the input. Fix this issue to don't happen. So anytime, exactly, what happened here is that before of this, what happened is that anytime you update this component, or you trigger an state update, therefore it's going to render these components, you now after React pass through the rendering mechanism, triggers trigger render and commit phase, it will run now this piece of code. So this setup code. So this is when you say, hey, each effect describe a separate synchronization process that can start and stop. Okay? And when you write and read your effect, think of them as individual effects from the effect perspective, rather than from the component's perspective. Is that how to start synchronizing and how to stop it. Here we define is that how to start synchronizing and how to stop it. Okay? And when this effect is gonna run. So in this particular case, I want you to this now run on every whenever this value changed. So you can say, hey, like so, right? I want you to now connect after every keystroke. Is that what you want? Fix the issue so it doesn't happen. However, there is a problem. Whenever you type into the message box input at the bottom, also reconnects to the chat. So you can notice this by clearing the input and console typing into the input. Fix this issue that it doesn't happen. So I only, instead of this, it makes much more sense to only reconnect when the chat actually changes. And then you send a data, right? And then you send the data. So the next challenge here is switch synchronization on and off. So in this example, an effect subscribed to the window pointer move. So we're subscribing to an event here to move a pink dot on the screen. All right, to move a pink dot on the screen. The dot is allowed to move. And follow your movement. There is also a checkbox. Ticking the checkbox toggle the can move variable state variable. Uh, but this state variable is not used anywhere in the code. Your tag is to change the code we so that when can move is false, the checkbox is tick off. Okay, is to change the code so that when can move is false, the checkbox is tick off. So what we can do here is to say, so when I want you to now run this. Okay, I want you to now run this. Can move. I want you to now run this. Okay. Based on this reactive value, and check if the can move if true. All right, then you can actually do this, right? Then you can actually do this. Run all of this code. That's right. Exactly. Then you can do this. Totally. Totally. Mm-hmm. Mm-hmm. So because now it's important to think in terms of the effect. So here you are synchronizing, okay? Here you are synchronizing. That's right. Here you are synchronizing. This is the setup code that will run when it's synchronized, okay? And when the can move changed, exactly, it's still running that. And when the change move change, then it's gonna do this. Okay, give me a couple seconds here because Mother Nature is calling again. I'm a new man. I'm a new man. Okay. And we're back. And we're back. And we're back. Okay. Okay. So. Okay. So we need to think in terms of the synchronizing and desynchronizing. Right? So this is a set of code. My intuition say that we can is put a logic here. Okay. As a way to say is, well, yeah, we can put some logic here as a way to say, hey, if mm, okay, as a way to synchronize and desynchronize. Okay. So we got is handle check. Handle check is this function handle move. Okay, is this function handle move. Handle move. All right. And set position. Okay. So my intuition says that I'm going to now call this update state here by saying is switch synchronization on and off. Okay, so when this component, so when, okay, so what we got here? So instead of actually putting this, I think it's this because after all we need to synchronize with that external system, which is the web API. So here we're gonna say is if the can move is true, now I want you to actually is to now I want you to actually is to do this, to actually update the position of that. Otherwise, don't do that. And that's it. So the idea here is that now, because we provide is the can move as a reactive dependency, so useEffect will say, hey, when this dependency changes, I want you to now verify it inside of my setup code as a way to update this state whenever the point exactly as a way to update this whenever the external system, in this case whenever an external event happened, an event outside of this happened, which is exactly what's going on. You can declare an effect conditionally. However, the code inside of the effect can use conditions. Exactly. And this is when they declare like so. Right? Alternatively, you could wrap the event subscription logic, okay, into an if can move condition like that. Also, this is another alternative here. It's a hey, if can move, I want you to now is run the setup code, the setup function, and you could wrap the event subscription logic. The event subscription logic here. In both of these cases, canMove is reactive variable that you read inside of the effect. This is why it must be specified in the list of the effect dependency. This ensures that the effect resynchronizes every change of its value. So far, so good. There is actually nothing mystical about it. And the other is investigate a stale value bug. In this example, the pink okay. In this example, the pink dot should move when the checkbox is on and should stop moving when the checkbox is off. The logic for this has already been implemented. The handle move. Event handler check that canMove state variable. However, for some reason, the canMove state variable inside of the handler move appear to be stale. It is always true, even after you tick on the checkbox. How this is possible? Find the mistake and correct the fix bugs. For example, like this. ESLint disable next line react hook exhausted depths. So because you define now this as an input check, you're actually anytime you're triggering that, you actually set, you actually call this the set canMove, okay, and you change that to true or false, okay. However, the hand move is now detecting canMove here. All right, it's detecting canMove and it's trying to update that, but the handle move function is not receiving any of its props as you might expect, and this is only run is one initially. That's what happened. So what happened here is that now this side code is say, hey, I'm start synchronizing and stop. Yeah, this is the two things that I'm doing. I'm starting synchronization here, okay, with the window add event listener pointer move, and then this, and I'm gonna run is this initially. All right, and I'm gonna run this initially. What happened is unless, okay, it's always true even after you tick off the check. But how this is possible? Find the mistake in the code and fix it. So you want in this ping should move when the checkbox is on, and should stop moving when the checkbox is off. And fix a connection. Okay. Investigate and a stale value bug. And most of the time here, is because this code will run, but when the canMove run. Okay, so anytime the canMove updates, now I want you to actually run this code. That's what happened. So why this is what? How I was able to identify this? Pretty straightforward. After all, this particular side effect is running only once, which is when you pass this array empty an array, and you want to know is when this actually is happening. You want to actually anytime you actually triggering this, now be able to run that function. In other words, is to actually is subscribe to that or not. You can also is or let this side effect run after every re-rendering, which is what it's doing here. So after every rendering, the side effect will run is yeah, after every re-rendering, the side code will run. After every re-rendering, the side code will run is uh, after every commit. Okay, if that is what you want. Okay. So we in here append that you can move because now that value will change. That because this is an state here is reactive. Therefore, it will change over time, which means is that when that change, I want you to now initially when you mount the components, call this handle move, all right, which is passing that, all right. You can even that reset that, and initially because you already passed that, and if you check that can move is true, if you have, for example, false, this is the initial state, all right. But if you pass now true, you are now rendering as a component is actually setting the value of this, okay? And now this particular callback, you are passing that as an event listener, which means that you tell it to react when this component mounts. Is like, hey, run the setup code, but in this case only once. And then when the component is unmounted, run the cleanup function code. Okay. Exactly. But as you can think here is doing resynchronization. Resynchronization. Did this did not resynchronize here. Okay. There is no resynchronization here. And if you never suppress the linter, you will never see problems with stale values. There are a few different ways to solve this bug, but you should always start by removing the linter suppression, then change the code to fix the lint error. You can change the effect dependency to handle move, but since it is going to be a newly redefined or newly defined function for every render, you might as well remove the dependency array altogether. Then the effect will resynchronize after every re-render. So that was quite straightforward. Fix the connection switch like this. React hook exhausted depth. React hook use effect has a missing dependency create connection. Create connection. And where do you get that create? Okay. Create connection, which is a function. Create connection. Either include it or remove dependency array. If create connection changes too often, find the dependent component that define it and wrap the definition in the use callback. So use callback, okay, and wrap the definition into a use callback. And even though it's telling you what to do, or you can pass that or write the definition inside of the create callback here. If you remove the linter suppression, you will see the error. The problem is create connection is prop, so it is reactive value. It changes over time. And indeed, it should, when the user ticks the checkbox, the parent common pass a different value of the create component of the create connection props. This is why it should be dependency included in the list to fix the box. The other is to actually now is it is a correct that creation connect is a dependency. However, the code is a bit fragile because someone could edit the app component to pass an inline function, and as the value of these props, in that case its value will be different every time the app components re-render. So the effect might resynchronize too often. To avoid this, you can pass is encrypted down instead. But okay, it's encrypted instead. You can pass this is encrypted for that, and then you create a connection down there. Oh, it's because it's creating here. In this version, the app component passes a boolean props instead of a function inside the effect. You decide which functions to use, since both create encrypted connection and create unencrypted connections are declared outside of the component. There aren't reactives and don't need to be dependency. You will learn more about this in removing effect dependencies. The next challenge is populate chains of selected boxes. Pick up line. Okay, this is actually a fairly common use case. Set planet list, pick a place. Place list map. Pick a planet, pick a place. Oh, but this is a planet list and place list. Here your rendering is that properly. Planet list and place list. Planet list and playlist. But here you are never is setting that. But here you are never is. Okay. In this example, there are two selected boxes. One box lets the user to pick a planet. Another select box lets the user pick a place on that plane. Exactly. So what happened is that initially is now loading that, right? And the question is, you are now populating the planet list, but what is the place list? Okay, planet list, they stay with the result of the planets API. The concurrently selected planet ID is kept in the planet ID state variable. You need to find where to add some additional code so that the playlist state variable is populated with the result of the planet plus planet's ID plus place API call. If you implement this right, selecting a planet should populate a place list changing the planet. Oh, but it's because when you say fetch data, which I'm assuming that this is part of that. Okay. Okay, so fetch data. So when you do that, and the thing is that because that actually depends on that, we can just do something like this. Run this async function, okay, like so. So no, it's fetch data, right? And I want you to now fetch data here as a way to say, hey, I want you to now, in fact, is not only is do this, but the planet ID that I'm getting from, okay, which is in this case is the result 0.id. So select that planet. You can here say is define accounts here, planet ID, like so. As a way to get is the first one, and then this is what you're going to pass down to there. You say planet ID and the places. Exactly, and the places here. So once you get that data, all right, so once you get that data, now I want you to set the planet, so which is here with the result exactly. Set the place list here by say set the place list here, set place list here, all right, and the other is the place ID as a way to now set the place ID and follow this particular pattern, which is now the ID, right? So as you can see here is now loading it like Laos, Spain, Vietnam, Venus. Of course it's not going to update that, but it's now changing a planet should change the playlist. Exactly. So the idea of this is that we can abstract this logic into its own component. And you can you can think as a separate process here, as a separate process here. And when the planet ID change, but again, this is quite cumbersome. This code is a bit repetitive. However, that's not a good reason to combine into a single effect. If you did this, you have to combine both effect dependency into one list, and then changing the planet will refresh the list of all planets, and the effects are not a tool for code reuser. Effects are not a tool for code reuse. Instead, to reduce repetition, you can extract some logic into custom hooks like use select option. Like this, you create your own hook, that's right, where you're going to now provide is that particular thing that you want to. List set select list select ID, and this is when you're going to now run that. Is the URL is the same, okay, return null, there's nothing happens here. However, if that changed, I want you to now fetch that. That's a way to prevent any duplication for that. Check the use selection JS tab in the sandbox to see how it works. Ideally, most effects in your application should eventually be replaced by custom hooks. Whether written by you or the community, custom hooks hide the synchronization logics. Custom hook hide the synchronization logic. So the holding component doesn't know about the effect. And you keep working on your app, you will develop a palette of hooks to choose from, and eventually you will need to write effect in your component very often. Okay. Okay. That'll be all for this video. Take care.